So, in this chapter, in last lecture we have studied about binary tree. So we have seen that binary tree is a defined on finite set of nodes and that either combines nodes. Okay, so we have seen that in binary having two types like array representation which form in a single table form, right, which we have seen in my previous lecture, and linked list representation which show the left child address and right child address in between data, right. We have seen this diagram also, linear link representation and array representations, right. So today we're going to see. So in that code of define the node binary trees are left node and right node. So there are left node and right node data which can be any object, right? So we have to define in self data. So node construction. So so we will see in our practical session this all. Okay. So now application of binary tree, express tree are used in compilers. Huffman coding tree that are used in data compression algorithm. Okay, binary search tree (BST). Okay, priority queue. These are the application of binary tree which we have studied in our data structure subject also, right? Because we having the subject of tree. So top left chapter in data structure. So now here types of tree. So these are the three types of tree. First, strictly binary tree, then complete binary tree, and third one is the extended binary tree. So let's see first strictly binary tree. Okay, so this is the type. Binary tree is nothing but is combination of both, means having two types. It's a combination of array and what link list, right? So here, okay, strictly binary tree. So this is the first types of binary tree, that is a strictly binary tree. So, a binary tree is a strictly binary tree in which internal node should have exactly two or none child. So binary tree strictly binary इसको कहते हैं जिसका internal node ये two child होना चाहिए या none. So see here in internal node having two child, right, and in this no none. So जिस tree में आपको two child और none child दिखेगी, that is called a strictly binary tree. Okay, keep in mind. अगर three child होगा, it's not a strictly binary. It's compulsory two and none. So strictly binary is used to represent algebraic expression. So it's used to represent the algebraic expression, right? So here in strictly binary nodes, internal nodes having only two child or none. So this strictly binary is used to express algebraic expression. It's used to represent algebraic expression where non-leaf node represent operators and leaf node represent operands. So you know very well operators and operand. What is the meaning of operators? So non-leaf node is represent operators and leaf node represent operands. Okay. Strictly binary data structure is used to represent mathematical expression. So this strictly binary, binary data structure is used to represent mathematical expression. So this is about the strictly binary which having two nodes, need to have only two child and none child, and this is leaf node is non-leaf node is means this is a leaf node which acts as a operand and one is operator, right. Leaf node is act as an operator, and this operand. Okay, then it's used for the mathematical it's used to represent the mathematical expression, right. uh, so after the strictly binary, this is the one type of binary tree let's see, the next point is a complete binary tree here. So this is the complete binary tree. You are here root, and you can see the parent, which we have studied how the binary tree is, right? Tree, what is a tree, what is a root, what is sibling, the then parent, then leaf node, level, depth, degree. We know everything about binary trees structure. We have studied in previous lecture only. Okay, so this is the second point of complete binary tree here. So a binary tree in which every internal node has exactly two children. That means all internal nodes have degree 2 and all leaf nodes are at same level is called complete binary tree. Means it's nothing, in this exactly two children must have. ओके मतलब वन चिल्ड्रंस नहीं चाहिए, जैसे कि यहाँ पे वी कैन सी, यहाँ पे जस्ट सफिशिएंट टू था, टू वन और टू के अबाव नहीं चाहिए, या तो वन टू और नन, बट यहाँ पे एटलीस्ट स्टार्ट फ्रॉम टू, वन इट विल नॉट कंसीडर हियर, that is not complete binary. If one children होगा तो इसको complete binary नहीं कहा जाएगा. Okay, so it's have exactly two and more. Okay, and here one, none and two, not about two here in strictly binary. In here in complete binary exactly two children we require. It's called, that is called the complete binary. So a binary tree in which every internal node has exactly two children. That means all internal nodes have degree 2. So you know very well degree 2 means what. जिस नोड की मतलब जिस parent ki two childs, okay, that is called degree 2. We have studied in our previous lecture also, right, about tree and about degree of a, degree of b, c and all, right. We have, I have expressed you, right. So here what, a binary in which every internode has exactly two children. That means all internodes have degree 2 and all leaf nodes are at same level is called complete binary 3. Okay, it is also termed as a perfect binary tree. Complete binary tree is also called the perfect binary tree. In complete binary tree, if there are n nodes at level 1, then at level I plus 2 there are 2 of n nodes. So this is about complete binary tree. So let's see the extended binary tree. This is the also type of binary tree. So here an extended binary tree is a transformation of any binary tree into complete binary tree. So किसी भी binary tree का complete binary tree में transformation, that is the extended binary tree. Okay, so is a transformation of any binary tree into complete binary tree. This transformation consists of replacing every null subtree of original tree with special node. These special nodes are called dummy nodes. So this transformation consists of replacing subtree of the every null subtree of the origin tree with special node. Okay, the full binary obtained by adding dummy nodes to binary tree is called as extended binary tree. So extended binary tree is nothing but is जहाँ पे dummy nodes contain होता है, that is called the extended binary tree. So you can see child is considered as a dummy node here, it's all child. So this is called this rectangle, the which see here in this diagram you can see the node which are represented by rectangle are the dummy nodes. Okay, this is the dummy nodes. In this tree में dummy nodes contain होगा, it's called the extended binary tree. Okay, so ये एक complete binary tree का एक tree को complete binary tree में transformation करना, that is the extended binary tree. Okay, so this is all about types of binary tree, that is strictly binary, then complete binary and extended binary. Strictly binary may must have two child only or none and one, not more than two. But in complete binary, exactly two. Okay, the degree of two nodes, that is the complete binary we can say here, right? So this is the used to represent mathematical expression. Okay, this trees and some first node is called, means parents called, one is called operand and another is operator, right? Then in extended binary is a completely transformation of the binary is transformation of complete tree. So node is called dummy data here. Okay, which is expressed represent in rectangle form. Okay, so about after this let's see properties of binary tree. So here full tree and complete tree, these are two properties of binary tree here. So a binary tree with n node has exactly n minus 1 nodes. In binary tree, every node except the root node has exactly one parent. So in a binary tree, every node except the root node has exactly one parent. Okay. In binary tree, there is exactly one path connecting any two nodes. In tree, you can see, okay, that connecting two nodes, right? So the maximum number of nodes in binary tree, highest h 2 raised to h plus 1. For example, number of nodes in binary tree, highest 4 will be 2 raised to 4, means listen, like this will be there. The maximum number of node in binary tree of highest, that is h, is 2 raised to h, 2 raised to h plus 1, 2 raised to h plus 1 minus 1. So this is you can say that, just this is, you can say the formula of means maximum number of node in binary tree of highest h is indicate like this. For example 4 will be highest. For example, binary tree of highest 4, suppose, okay, binary tree highest, binary tree height 4, okay, will be now show represent like this, okay. Binary height as is a 2 is represent like this. So is if binary is having 4 height, then it will be represent like 2 raised to h, that is 4 is nothing but is h equal to 4, okay. So height indicates numbers indicates, right, 4. So here now we have to put like 2 again, 4 minus 1, sorry, 4 plus 1, then after this minus 1, okay. So that is 4 plus 1 minus 1 is nothing but you can calculate now, that is calculation will be 31, right. So this is about the this is about the property of heights, right. Then the minimum number of nodes in binary of the highest h plus 1. Number of leaf node in complete binary is n plus, so number of leaf node here, number of leaf node in a complete binary, in a complete binary tree, which is n plus 1 upon 2, okay. Number of leaf node in complete binary tree, that is n plus 1 upon 2, okay. So so in complete binary, number of external node, number of internal node plus 1, okay. So that is number of external node upon, so number of external node equal to number of external plus, in complete binary tree, number of leaf node in complete binary, that is the n plus 1 upon 2. So you can say this is the formula of here, this is the notation how to represent this complete binary and how to represent the height of the binary, right. So now in complete binary, if height is nothing but this level, we have measured level 1 2, how to measure level of trees, right. So in complete binary, if there are nodes level 1, then level 1 plus 1 means if there is nodes level 1, so n is indicate 1, so 1 plus 1 equal to 2, right. So that is the 2n, you can say that upon 2, like this, okay. So a full binary tree is binary tree which each node has exactly 0 or 2 children. Full binary is nothing but is a tree binary tree in which each node has exactly 0 और 2 children. वही जो full binary tree होगी इसके children या तो 2 होने चाहिए या तो 0, ना 1 होने चाहिए ना exactly 2 and 0. Okay, so this is about the properties of binary full and C. A full binary is having exactly 2 children or 0 and 1. Okay, okay, 2 and 0, not more than 2 here. Okay, then after this a binary traversal. So first is a pre-order here first. So this is about binary tree traversals. So first one is a pre-order, then in order and post order. So consider the binary tree. We know binary tree now. Let's explore each pre-order. This travels is also known as a depth first order. Pre-order is also called depth first order. In this technique, the traversal order is root left right, that is process data of root node. Root left right means here suppose is the one of the three we will consider root is process from left to right, that is the pre-order. Okay, left to right. Okay, first travels the left subtree completely, then travels right subtree. मतलब यहाँ पे प्री ऑर्डर में फर्स्ट वो लेफ्ट सबट्री को कंप्लीट करने के बाद then it will start from the right subtree, right? In the above example, if we perform the pre-order technical traversal, then first we start from its root, which is A. Okay, suppose we start from root, okay, which is A here. Next we move to left no subtree of A. So we have to suppose we can copy this here, then you will get better in pre-order, right? So see here what is about pre-order. In above you can see in diagram figure you can say that uh, uh, first we start from root A. Next we move to left subtree, that is so visit left child, that is a B, again has D and F, right? We have to complete pre-header. We have to complete first subtree from left side here. Okay, A. Next move from B. Then again B has D and F. Add is left and right child. See left and right child, right? So first we visit a left child, that is D. So again D has suppose D has again I and J, suppose. Okay, D has the children I and J, like. Okay, then right child okay, so we have to move first again left child I, and then J. Okay, so we visit the left child I here, like, and then leftmost child, then we move to the right child J, suppose here I, and suppose here J. Okay, and then okay, because I does not have any child, suppose D having I and J child. Okay, so we move here I and J, but we don't move here after downside of J, because suppose J I doesn't have any child. Okay, next we visit B's right child, which is F. Okay, means suppose here first we visit start from the root. Okay, then we visit the leftmost child. pre-order में always left side में move करते हैं. Okay, और left side में move होने के बाद suppose D having child, okay, and E having. So first we will do from, we start from the D leftmost child, suppose I है और J. Okay, और I और J में कोई child नहीं है, तो हम वहाँ पे stop करने के बाद we will move from E here. Okay, suppose got it. Now we shall then now go for A as a right child is C. Go for A is right child, so visit it again. C has suppose list child, right child, so move the child like C having child. Left child is which is G, but G have only right child. Okay, suppose left child C has, sorry, F here, okay, and F don't have any child, so we have to move again G, and to move from the left side, that is the H, which is the which is leftmost, and then move to I, and after so we stop the process. After this we have to stop the process. So the pre-order may always start from the leftmost, and then leftmost subtree से start करके end to हम we have to complete, then rightmost, then we have to from after right we have to start from the again left, right? If right have don't have child, so we have to process from G, and then left. If having again child, then we have to move from this side, and then child end होगा तो वहाँ पे we have to stop the process. So pre-order travels is about, तो ये pre-order travel कैसे करेगा, just like this. इस एग्जाम में आता है, तो tree with the help of tree you have to express की like this happen. So first A, right? Then A के बाद we have to go from B. B के बाद we have to go D. Okay, D. अब suppose D का कोई child है like I and J, तो we have to do I. We have to write like this. अगर नहीं होगा तो we have to stop here. Then E. Okay, फिर बाद में we have to again go A से C, right? जैसे हमने देखा C. Then C के लेफ्ट में कौन सा child है, F. Then G. Then H. Then J. Okay, here I is written. Okay, consider like J. Okay, yeah. Okay, so यहाँ पे is stop. Okay, so this is about the pre-order tree, pre-order traversal. Okay, now let's see the in order. So next is the in order traversal. In order. Okay, I hope कि आपको समझा होगा कि pre order means what, right? Now in order, this travels is also known as left first order. In technique, they travels the order left to right, left root to life, that is first process left subtree, then process current root node, and process right. So in this example binary tree, first we start from the left child of root A, which is B, but again B has left child D. So we move to D again. D has left child. So we visit I because it's left more child in 3. So then visit its root node D. Then visit right child. Means if this having right child here with this above have complete this left part node. Then visit B. Move to the right, which is F. Then visit left, then with A left part. Now visit A, move to the right part. A has C, then its right child, again C have left child, that is the F. Then F have only right child, that is F don't have right child. Then we have to move from G, this is having the H and I. So then visit C and move to the right. So in C has the right child, which is a almost child. So visit in or travels about the example list means here हम लोगों को just we have to move from left to right. So we in order हमें internal node only we have to write from left to right like this only. But यहाँ पे हमें just internal order हमें maintain करना है, root mention नहीं करना है this, right? So here हम लोगों को देखना हमें डाउन साइड से चेक करना है, मीन्स फर्स्ट लाइक दिस I H, then like this. Okay, like this. Now suppose D I D, then C D E B. Okay, इंटरनोड में कैसा होगा, 1 minute. इंटरनोड में कैसा होगा, we have to move from first like then suppose D, अभी यहाँ पे नोड D, then लेफ्ट साइड से हमें मूव करना है, ठीक है? then D B D B and E. Okay, then DBE, then अगर यहाँ पे कोई child नहीं है तो we have to stop. देन मतलब हम लोग इन ऑर्डर में ऐसे टाइप करना, वी हैव टू राइट रूट, बट हमें डाउन साइड से अपर जाना है। यहाँ पे हम लोग अपर स्टार्टिंग टू एंड लेफ्ट राइट किया है, जैसे लाइक दिस वी हैव टू गो फॉर डी ई बी। देन अब यहाँ पे कुछ नहीं है तो फिर हैव टू लेफ्ट वी हैव टू राइट एच, सॉरी एच, देन जी, ओके, एच जी, ओके, एच जी, then leftmost having SG, then I, C, HGI, then again FCA, SGI, then FCA। मतलब यहाँ पे हम लोग रूट टू एंड तक गए, और यहाँ पे हम फर्स्ट लेफ्ट मोस्ट से लेके एंड टू रूट, मतलब इन ऑर्डर में हमें एंड टू फर्स्ट ऑफ वी हैव टू टेक फ्रॉम रूट, सॉरी लेफ्ट मोस्ट साइड दिस साइड, तो यहाँ से लेके अप टू दिस कंप्लीट होने के बाद, ये कंप्लीट होने के बाद हमें रूट तक जाना है, और यहाँ पे हमने प्री ऑर्डर में हम लोग रूट से एंड लिफ्ट तक गए। ओके, so this is about pre-order and in order. Okay, so I hope कि आप समझ गए होंगे। सो नाउ प्री ऑर्डर में स्टार्टिंग टू एंड हमें ट्रैवल करना है। ओके, लेफ्ट मोड, दोनों ही लेफ्ट मोड ऑर्डर कंसिडर होती है, एंड इन ऑर्डर में हमें डाउन टू अपर जाना होता है। ओके, फॉर्म इज सेम लेफ्ट टू राइट, देन फर्स्ट ऑर्डर। So the first order travels, the left subtree travel first, post order travels, then right subtree travel, first order travels, then root is travel. In above example, first we try to visit left child node A, but A is a left child root node or left subtree, so we try to uh, left child B, D, then subtree. So we have to, so here we have to move from like this, I, J, D, then let me draw this figure first here, then you can understand. uh, Post order. Okay, suppose, okay, let's copy it, then you will get we will see how to move, मतलब move कैसे करना हम लोग डायरेक्ट वही देखेंगे। ओके, आपको क्या you understood now कि लेफ्ट टू राइट जाना है, राइट? सो अगेन नो नीड टू एक्सप्लेन अगेन कि हम लोग कैसे परफॉर्म करना है, राइट? सो सपोज हियर A, okay, so right here this is A, okay, then suppose this is B, okay, then I will just mention now कि हम लोगों को कैसे मूव करना है। ओके, I will just give the link, means not link, like this form। ओके, just you understand कि हम लोगों को कैसे परफॉर्म, प्री एंड पोस्ट, प्री एंड इन ऑर्डर आई एक्सप्लेन यू, सो पोस्ट ऑर्डर या कंसिडर करना कि हम लोग कैसे ट्रैवल कर रहे हैं। ओके, then I will just give the link, let me do first complete this, then D, after D I, and J, then after we require one, we require 2 3, then let me take 1 minute। Okay, so let's do this, add to link, then BD, then F, so then again we require that is H, then after H, G, then One more last. A. Okay, so let's use the connection here so that you will understand. A. Then after A is the root, right? A is the root. Then let's take the then again. Okay. Then B is having D and F, right? Okay. Then B having okay. Then let's complete this diagram first. B having two child, that is I and J. Okay. Now we want to complete this C also having two child, G and H. Then G having one child, K. Okay. So this is the diagram, that is the A root. A is a root. Okay, so this is about your post order here. In this diagram, here you can say this in this diagram. Okay, first we start from the left child of root node A, huh? Then which is a B, but again B has left child D. So we move to D. Again D has left child I. So we visit I because this is the leftmost child in tree. It does not have any child. I doesn't have any child, right? Then visit its root node D, and then visit its right left child, that is child, that is J. Then with this we have complete the left part of node B. Then visit B. Next move B's right child, which is F. Visit F. Then with this we have done A's left part, right? First we visit the B, then okay, this is we have completed. Then now visit A and move to the right part. A has C, then its right child AC, then C have left child, that is the left child is G. Okay, and G have only right child, that is K, that is K as a child, right child K. Then G does not have any left child, right? So visit G, then visit K. With this we have done uh, leftmost child, leftmost part of C. Then visit C and move to the right part. Visit C and move to the right part of C. C has right child at, and which is the rightmost child. So visit H and stop the process. Okay, so in order. So here in order, the series will be like this. I first visit I, then root node D, then child J, then B, then F, then A, then G, then K.
एनी प्रॉब्लम, मतलब ये समझ में आ रहा है क्या चल रहा है, ग्राफ एंड ऑल? यस, अब्दुल्ला, अफरा, भूषण, फैसल, फैजान, सुमेर, बोलो 2 मिनट है, वी हैविंग ओनली 2 मिनट्स, एंड होने वाली मीटिंग।
Yes,
हेलो,
ma'am.
समझ रहा है, लेक्चर समझा?
हाँ मैम।
ओके,
Yes, ma'am.
जी
ओके,
मैम।
ओके।
C, H, stop. So this is about in order, post order, and pre-order. So today's lecture stop over here. Thank you.